Hello, I'm your host, Walter Schwabe. We're live here at the Analytics Big Data in the Cloud Conference at Fantasyland Hotel in Edmonton, Alberta. And you know, what's really interesting is we're talking about a lot of analytics, big data in the cloud. And I'm actually joined by Dr. Bob Este, who is the Business Development Officer for the Institute of Space Imaging Science at the University of Calgary. Hello, Bob. How are you?
Good day. It's really good to meet you.
It's nice to meet you. So, this is a fascinating topic, because first of all, we're going to talk a little space.
Sure.
We might talk some data, but we're going to talk space first, and I love this kind of stuff. So help our viewers understand, first of all, the implications of the project that you're doing, the space array, because it's a pretty big project, isn't it?
Absolutely. What we're talking about here is it's the biggest science project really ever undertaken by humankind. And you know, if you stop and think about that for a second, you can think back to NASA space programs or the genomic sequencing projects.
Right. Both very large projects.
Yeah, and neither of those projects, for example, are over. All of the spin-offs and all of the implications continue today. What we're starting with the Square Kilometre Array project, which, by the way, has been in planning stages for more than a decade, is a massive global collaboration among a number of countries, all of whom have agreed that building a project of this size and this extent and nature is crucial for us to understand essentially our origins, the beginnings of the universe. We're going to be examining whether some of Einstein's theories actually can be verified. Some of them already have, of course, but there's a lot more work to be done in that area. And I think one of the other things that's really interesting about it is the fact that the data challenges that are associated with this project are the biggest that, again, humankind has ever faced.
Well, with the biggest project ever, you're going to get the biggest data ever,
Absolutely.
right? I mean, that just makes sense.
Yep.
So let's do some fundamental stuff
Please
first.
go ahead.
Where is the Square Kilometre Array situated?
Okay, it hasn't been built yet. Precursor projects have been built in different locations. There has been, if you like, a global competition to determine which location on the planet is the best.
Oh, okay.
And the criteria that are used for that sort of thing have to do with, for example, radio quiet. If you're going to build a radio telescope, you don't want to build it in Manhattan.
Right, yeah. You get a lot of white noise there.
More than that. You get so much radio interference that it would be silly to even think about that.
Right.
So you want to build it in a place that's radio quiet.
Area 51 comes to mind. It's pretty
quiet. Well, I don't think it's that quiet. So the two countries that have been finally shortlisted that provide the best opportunities for radio quiet are Southern Africa. So that's South Africa and a number of the other countries in Southern Africa, and then all the way over to Mozambique, actually. And then if you look at Australia, especially the outback, and the region that's being contemplated here goes from near Geraldton, which is northeast of Perth, all the way out to New Zealand. So we're talking about a very, very large geographic area for the purposes of building this thing.
Wow.
And the competition hasn't been resolved yet.
Okay, interesting. So let's talk just quickly on the competition. You don't have to go into too much detail.
No worries.
But how would one win? I mean, you talked about quiet radio, but how does one win this kind of competition?
Well, Southern Africa and Australia and New Zealand over the past number of years have done a really wonderful job of demonstrating to, if you like, the Square Kilometre Array group that's evaluating which site would be best, what their capabilities are. So investments have occurred in both areas with regard to infrastructure, education. If you start thinking about it, and you're engaged in this kind of mega project preparation, you're going to want to do the absolute best job possible.
Right. You're going to want to have the right people available, the right scientists and so on, very specialized.
Yep.
Okay, great. So let's talk now about the data. And, of course, because it hasn't been built yet, we don't have, and correct me if I'm wrong, but I'm making an assumption here, that we don't have massive amounts of, Square Kilometre Array data yet to crunch from this particular project.
From this project, that's
Right.
correct.
So what do you anticipate, though, when you say it's the largest in the world? How can we get a little bit more specific than that?
Well, a real nice way of viewing it, and in fact, I just shared this with the group that we were in about half an hour ago, to allow people to get a visceral sense of what are we talking about when we say,
Right.
the biggest.
Yeah.
And by the way, before I say what I'm going to say, I just want to mention that there are other projects underway right now in the radio astronomy world that are already generating large amounts of data.
Right.
The Arecibo telescope, for example, in Puerto Rico is an example.
That's a famous one, right?
Yeah, that's right.
Yeah.
And the Very Large Array in New Mexico does the same kind of thing. In fact, data streams from both of those telescopes come to the University of Calgary for analysis.
Oh, I didn't know that.
Yeah,
That's
we do
interesting.
that. Yeah, we partner with other universities on that. But
You guys have got to have some serious cloud firepower over there at the UC to be able to crunch some of this data.
That's a whole other question.
Well, it is. Yeah.
So let's talk about how much data are we really thinking about here. When the SKA is actually built to full capacity, and it's going to take a number of years to build this kind of project, as you can well imagine. Remember that the baseline of the spiral arms that are going to be built in these desert areas are about 3,000 kilometers long. So you have to think about that being, essentially wired up with fiber optics and all that sort of thing.
That's a short holiday to get from one side to the other.
If you could walk that far. Yeah, and you've got all the dishes that have to be built. So you imagine, if you will, although the decisions have not been made on the types of dishes to be used, but in general, you're talking about dishes with approximately 15 meters in diameter. You'll have 3,000 of those things stretched out over these spiral arms in either country, whichever one is chosen.
Right.
And a number of other different kinds of antenna types as well. And then the infrastructure connecting all of them. The story I told in the session that we just came from a few minutes ago, just so that people could get a sense of how large this is, not physically, but in terms of the data flow,
Right.
is that if you stop and think that you're going to be going home this evening, and you might turn on your television at home, and you're going to sit down with your family and maybe watch the news or a movie or something, and say you've got a 50-inch HD TV, a lot of people have those things, and it's a 1080p television or something like that.
Sure.
And if you think, okay, I've got a DVD here in my hand, I'm going to stick that into the player, and I'm going to watch a movie. Okay, who out there hasn't actually watched a DVD on a big screen TV? Probably most people have. Well, if you think about how much data are crammed into that DVD, if you could reduce the playing time of that DVD down to 1 second, and then play 56,000 of those at a time,
Right.
that's how much data will be coming down from the square kilometer array per second,
Wow.
24/7, 365. And I want you to imagine that number will only increase over time with new technology developments and that sort of thing. So if you wanted to ask yourself, how in the heck are we going to deal with that?
Right. That was my next question.
Yeah.
So, okay. So we're human beings. We're talented human beings. In your case, the team that you're with, and then sure, it'll continue to grow as the project goes. But, yeah, so how do you, break this, data down? And, of course, actually, that's been a common theme today.
Sure.
With Hadoop and other discussions about ecosystems that handle big amounts of data. But how do you, break that down into something that displays that you can say, oh, okay, this is something that's actionable for us?
Well, part of the answer to that question depends on who's asking the questions.
Right.
So different scientists, for example, will have different ways of thinking about those data. And different scientists will say, well, I want this part of those data. Another guy would say, well, I want this part to answer the questions I want. So first there's some selection that has to take place. There's also data reduction that's going to be required, because the number that I just talked about, like approximately 57,000 HD TV movies per second, that's raw data.
Right.
Those data are going to be reduced through various techniques to getting closer to the answer to your question
I see.
about the kinds of things you really want to pull out of there. But if anybody stops and thinks about it for a second, do we have technologies today that can do that type of thing? What about the storage side of this?
Right.
If you're going to have all these data crashing down on you constantly, and by the way, the scientific lifetime of this project goes out to 2070.
Wow.
Wow.
Yeah, okay.
All of a sudden...
That number's really big.
Yeah. All of a sudden, it becomes almost unimaginable.
Yeah.
So the challenges to every aspect of technology development here, having to do with data reduction, analytics, storage, transmission, all of those things, we're up against the boundaries, the edges.
Right.
So the innovation pressure that is now being applied to every sector that could conceivably be involved in this.
Yeah, is
huge.
huge.
People have to stop and think, well, wait a minute, maybe our product line is going in the right direction, but how are we going to do this?
See, you guys in the radio telescope world tend to think big anyways, right? Because you're dealing with the universe and you're dealing with big numbers all the time. But so I find it fascinating. But we've got a project here we're talking about coming into Alberta at the U of C that is actually causing you guys a little bit of headache and pain in terms of how you're going to deal with it. And I say that in a positive way, of course, but it's getting you guys to stop and think about, because I've watched many shows and seen many things about, as I said before, I love this topic generally.
Oh yeah.
Not nearly smart enough to keep up with it.
I'm not so sure about that.
But I love that. And you're thinking about the numbers that we're talking about, just in distance from here to A to B. Massive. And then when we talk about the amount of data that you're going to be collecting from now until 2070 when it comes online. When is it expected to come online?
2024.
2024? Well,
10% will be in 2019 probably.
Okay.
And
12 years out. Give or take.
Yeah, give or take, yeah.
Okay.
We're looking at a developmental phase, if you like, to ramp up.
Right, okay, fair enough.
But we'll start getting usable data, actually, in relative terms, quite quickly.
Yeah. Okay.
So, again, the challenges are now.
Yeah.
In fact, the challenges were 5 years ago when we...
When you're in the planning stage still, yeah.
Well, yeah, and that's what's so exciting about this. You were right to sort of like use the phraseology about the type of challenge this is. It doesn't cause headaches. It causes great excitement, because if you think about it, the challenges that we're trying to deal with are applicable to every data environment. It's not just radio astronomy. It's medical imaging, it's security, it's finance. Wherever there are massive data flows, which are only increasing.
Right.
It doesn't matter where you go today, that's what's happening.
There's more data, yeah.
Yes.
Well, going back to the days when everybody was talking about the paperless office, and realizing now that we have devices that create more paper than we ever thought we would ever want. So it is a fascinating project. And again, for those viewers who are just tuning in, I've been speaking with Dr. Bob Este out of the University of Calgary, and the Square Kilometre Array, and is the largest project of this type. Now, Dr. Este, where can people go if they want to find out more information about this project? Where can they go online?
Well, I think it would be fairly obvious to most of the people who are having a look at what they're seeing now that if you do a Google search for SKA, you're going to find a couple of things. One, you're going to find a grunge band in Calgary. That's not us.
Oh, come on. You guys don't grunge it up on the weekends?
It just sort of happened to be that way. And so if you do a Google search for radio telescope SKA, you're going to get it.
Okay.
One of the other things that might be interesting for the viewers is to think about Googling Cyber SKA as one word, because that's a project that we've just finished as of, let's see, our Canary funding ended on December 31st for the first contract that we had with them. Then we had a 3-month extension. But the Cyber SKA project is also out of the U of Calgary, and it was the beginning of framing up some of the cyber infrastructure as a demonstration for the entire project.
Sure.
So that was really exciting for us to do that for 2 years as well, because we started thinking, well, how in the heck can we just begin to nibble around the edges of this project to make it work.
Right.
Now we've got a great platform. So the Cyber SKA example also is worth having a look at. People can examine it, read about it, and recognize that we've developed a tool that will end up being extremely useful, not just for the scientists who are signed up to it, but as an example of the kind of tool development with our industry partners that really makes a difference. So we're beginning to climb that development ladder,
right,
with that Cyber SKA. So in answer to your question, the big project, the one that has been in planning stages for more than a decade, is SKA, Square Kilometre Array. And then there's the Cyber SKA, which is our, quotes, little project
right,
at the University of Calgary, and it's still flowing ahead.
Still ongoing.
Oh yeah.
Now, just before I let you go, because I know that there's other festivities tonight that you can go and partake of, but why don't you just quickly mention some of your colleagues that are here at the conference with you,
sure.
and maybe some of the organizations they're with, unless they're all with the U of C, but just maybe give them a quick mention and letting folks know out there who else is involved. And I'm sure on a project in the world's largest project, there's got to be the world's longest list. But you know, who are some of the folks that are working on this?
Well, at the University of Calgary, I should point out to everyone who's looking at this that actually the gentleman who's just looking over her shoulder over here, he's 6'7" with white hair. In case people are wondering who I'm looking at, that's Dr. Russ Taylor, and Russ is a full professor at the university in physics and astronomy. He was one of the originators of the Square Kilometre Array project with a small group of radio astronomers more than a decade ago, when they all sat down and said, well,
let's think big.
Exactly. What are we going to need in the future to begin to address some of the questions that we have? So Russ has been fantastic in terms of being the engine behind all of this.
Right.
I should also mention, let's see, well, I'm looking at the other people who are standing there. We've got Rob Simmons, who has been in the Grid Computing Center and is now the technical coordinator for the Cyber SKA project that I mentioned a moment ago. Mm-hmm. We have many other people also scattered all over the place.
I would think so, yeah.
At UBCO, which is UBC Okanagan, UBC Maine. We have partners at McGill and partners at Cornell in New York. We also have industry partners, IBM, for example. IBM Canada has played a very important role in allowing us to move forward with our Canary project 2 years ago.
Providing some infrastructure there.
Absolutely. Yeah. And we've also worked directly with IBM Corporate, if you want to put it that way, based out of New York. So we've had great collaborations with those folks. Cameron Kittle is standing there as well. And he used to be employed by the university, now has moved over to Calgary Scientific, which is also one of our industry partners. A fantastic network of collaborators and developers so that we can move forward on all these fronts that I've described to you.
Well, Dr. Este, congratulations on such a wonderful story, such a wonderful project, and thank you to all of yourself and all your colleagues for taking on such a massive challenge and an opportunity to learn. And I know that this is going to impact my daughter, who's 7 years old. This is going to be stuff that she's going to start, getting down to that age.
Absolutely.
I'm not going to be around in 2070 probably, but you never know with medical advances, right? But thank you so very much for speaking with us here on Fuse Logic TV. Ladies and gentlemen, if you've just joined us again, Dr. Bob Este with the U of C. Stay tuned. We're going to have more interviews coming up for you right away, and we'll be back in just a few minutes.